Okay, let's go ahead and start lesson 2.4, which covers scientific notation in all of its glory. So the steps for multiplying by a power of 10, I just want to kind of, I know put on like the steps, but I just want to show you what scientific notation is first and foremost. Now, this number right here, 3.7 times 10 to the 12th, is considered in scientific notation, right? There's a lot of different ways, a lot of different answers for a scientific notation problem, but this is just one of them. But you've got, what I want to point out here is for this front number right here, the 3.7, it is considered in scientific notation because that front number is between 0 and, I'm sorry, not 0 and 1. It's between 1 and 10. And it could also be equal to 10. So it could be equal to 1, greater than 1, but it has to be less than 10. So it's got to fall in there. So if we, if we move the decimal over, if I move the decimal right here, well, now it's 37. That's definitely not between 1 and 10. Okay, now it is 3.7. And if I move it over here, it's too small. It's less than 1. It's between 0 and 1 now. So where the decimal is matters. So we have to put it right there. So that's when we put something in scientific notation, this front number right here, this first value, this factor, has to be a value between 1 and 10. It can also equal 1. It could be 1.0, but it cannot be 10. But it's got to be between 1 and 10. All right, now this other number right here, your power of 10, is telling you how far to move the decimal. Okay, so how far does the decimal move? And the power of that 10 is going to tell us how far it's going to move. So in this case, it's a 12. So that means we're going to move the decimal 12 digits or 12 units to the right. So we're going to move it 2 to the right, 12 to the right, not 2. All right, so here, let's go ahead and get started here. So we're going to multiply 9.5 times 10 to the first. That just means we're going to move that decimal over right here. We're going to move that decimal over 1 place. That is it. So that's going to become 95. Now it's a whole number, and you don't necessarily need to show the decimal when it's a whole number, but I'm just going to show you that now it's there. So if you wrote 95, that's perfectly fine too. All right, for number two, we're going to take that out of scientific notation, and we need to move that decimal over. So we need to move this decimal right here to a spot so that that number, so the non-zero numbers make a value between 1 and 10. It could be equal to 1, but it's got to be less than 10. So we've got to move that. So that's what we want to do. So we want to move that decimal over, we want to move it to right here. So move it between the 3 and the 2. All right, we move it between the 2 and the 7, that's 32. That's way too big. That's bigger than 10. All right, right here, that's 327. That's way too huge. That's even bigger. If we move it right here, it's too small, 0.32. I'm kind of truncating here. I'm not saying all the digits, but you know what I mean. So we want to move it between the 3 and the 2. That's where we want to move it. Now, how far did it move when we did all that? Well, it moved a total of 1, 2, 3 places. It moved 3 places. All right. So this, when we change this, we're going to write this as 3.271, 3 and 271 10,000s, or I'm sorry, thousands. And then All right, and then what we're going to do is okay, for number 2, what we're going to do is we're looking at the power of 10 here, and that's got a 5, meaning we want to move the decimal over 5 places. Okay, so that's what's going to happen. So this decimal right here is going to move 1, 2, 3, 4, 5. So now it's between the 7 and the 1. So in this case, we're just converting it into standard notation. That's not scientific, but we're taking it out of standard scientific and putting it into standard. So that becomes 327.1. That's where the decimal is now. And all those other zeros that were in front can drop off. We don't really need those zeros anymore. They just drop off. They were necessary for the decimal, but they're not necessary now. All right, for number 3, all right, this one has a negative exponent, therefore we're going to move it left. So if it's a whole number, by default, the decimal is right there. It's right after the ones place. And we're going to move that over 3 places. So you're going to move it over 1, 2, and then we ran out of numbers. But that doesn't mean we didn't run out of places. So we're going to have to put a 0 in its place right there. So that just means when we write it all out, we have 54 thousandths. Okay, so the decimal was right here. It moved 1, 2, 3. See what I mean? So that's what's going on that problem. All right, on number 4, this one has a negative exponent as well. And we're going to move the decimal over 7 places. Now here's the thing, we're moving it, if we move it over 3 places, it's right in front of the 4. So we just need 4 more places. So we might as well just add 4 zeros. And there it is in standard form. That's what it is. So it was here, it was there, and then it moved 1, 2, 3, 4, 5, 6, 7, right there. So it moved over 7 places. Okay, for number 5, 6, and 7, this is basically the same thing. We're just going to write it back into standard form here. And for number 5, it's got a positive power of 10, positive 3. So we're going to move the decimal over 3 places. So that is what we'll do. So the decimal is right there. It was here, it moved over 3 places. It went 1, 2, 3. There's where it is. Okay, for number 6, this one has a negative exponent. We're going to move it left. We're going to move it left. So we're going to move it how far to the left? 2. Okay, so the decimal was right here. And then it moved over 2 places. 1, 2. And that's where it is now. Okay, again, that's just so you guys know, this is called standard form. Because we're taking it out of scientific notation form and we're putting it into standard form. Same thing with that one. All right, number 7. All right, this has a power of 4 for the power of 10. And it's positive, so it's going to move over 4 places to the right. So we got 3, 9, 0, 4, 0. So that's where the decimal is. I want to put a comma too. You can do that, make it look a little prettier. So that is it. 39,040. That's it. But you don't need to do that. I mean, you can just write it as, just write like this. You don't have to show the decimal. If it's a whole number, we know, because we're good at math and we know how numbers work, we know that the decimal is right there. It just doesn't have to be shown. All right, for these examples, we're going to put them into scientific notation. That's what we're going to do. So for number 8, the decimal is right here, and we need to move it to such a spot so that the number is greater than 1, less than 10. All right, so in order to do that, we need to move it between the 1 and the 5. So now you got 1.5 times 10. Now let's figure out what the power is. Let's figure out the power. So how far did the decimal have to move? Well, it moved how many places? 1, 2, 3, 4, 5. So it moved 5 places. So there you go. So 1.5 times 10 to the 5th. And that's in scientific notation. For number 9, we want to move the decimal between the 3 and the 4. So that becomes 3.46 times 10. And let's figure out how far the decimal move. You have to put a box there where the power of 10 is. I'm just doing that to show you where it moved or how far it moved. So the decimal moved 1, 2, 3. So 3.46 times 10 cubed. Number 10. So we have an 8, a 9, 11. Okay. Leave it for a math worksheet, not to have the numbering correct, right? I mean, that's just so typical. All right, so now we want to move this decimal between the 6 and the 7. Between the 6 and the 7. Drop all those other zeros that were before it. Oh, I totally forgot. On number 9, sorry, back to number 9. This should be -3, by the way, -3. Because it moved, when we move it back to standard form, it's going to move left, So, and also think of it, it's a small number as it is right now in standard form. 346 100,000. It's pretty small. That's a very, very small number, relatively speaking. But yeah, that should have been negative. Sorry about that. I was just thinking of that because this next one is also negative. And I just remembered that should be negative. So we're going to move the decimal over 1, 2, 3, 4, 5. So it's going to be -5 power. -5. All right, in 2015, New York City's population was approximately 8,550,000. And so the decimal is right there. We want to move it between the 8 and the 5. So you got 8.55. So all the zeros after that aren't necessary anymore, so we don't need to show them. And that's what the power of 10 is for. So we're going to move that decimal how far? Well, it moved over 1, 2, 3, 4, 5, 6. So there's the population of New York in scientific notation form, 8.55 times 10 to the 6th power. All right, now steps for performing operations with numbers in scientific notation is that let's go ahead and write down these notes. We've got all right, so you're going to use the product or quotient rule for exponents only, and multiply and divide the way you do normally. And then there's one more rule here. And it's if needed. So if needed, adjust the value back into scientific form. So sometimes when we do the multiplication or when we do the division, we don't get a number that's necessarily in scientific form. Like number 14, let's start right off the bat here. Number 14 that works that way. So when we multiply the 3 times the -8, that's -24. Now that number is not in scientific notation, right? The decimal is right there. So we want that number to be between 0 and 10. I should have said also like plus or minus. It could be between 0 and -10 as well, or between 1 and -10. All right, and then times 10. Now we're going to use product rule for the powers, meaning we're going to add them. So 6 plus 3 makes 9. Okay, and then here's where the adjustment takes place. We need to move that decimal over one more place. Move the decimal over one more place. Okay, and so now let's rewrite it one more time. So now we have -2.4 times 10 to the 10th. That's it for number 14. For number 15, do the same thing. We're going to do 6 times 9. So that's 54. So the decimal is right there. Times 10 to the, now if we do product rule, -6 and 13, -6 and 13 makes 7. And this isn't in scientific notation either. We move the decimal between the 5 and the 4. So now we have 5.4, 5 and 4/10 times 10, and then add 1 on to 7. Because we moved it one place. If we moved it 2 places, we would have to add 2, or 3 places, or 4 places. Relative to how far it needs to move, that's how far you need to adjust your power of 10. All right, number 6. Now, when we do 8 divided by 4, when we do the division here, 8 divided by 4, that's 2. All right, so that comes out nicely. That's in scientific form. That's the way you need it to be, at least. And then let's apply the quotient rule to the exponent. So we're going to subtract 8 minus 4, and that makes 4. So 2.0 times 10. You don't have to write it that way. You can write it like this. Either way is fine. All right, number 17. When you guys do 5 divided by 2, 5 divided by 2 is 2.5, 2.5. And apply the quotient rule here. Now, when we do 4 minus 9, when you do 4 minus 9, that's -5. And that is okay. Now, this is one example. This is one of the examples here where it's okay to leave the exponent in negative form. Okay, so you do want to leave it in negative form. If you don't, if you change it to like 1 over 10 to the 5th, mathematically it's not wrong, but scientific notation wise, we don't want it to look like that. We want it to look like just like it is right now. Okay, that does it for chapter 2, everybody.